Hello. Thanks for having me. This is my first YAPC, so thanks everyone for being so welcoming. Yeah, thanks. So just a quick show of hands. How many people in the room identify themselves as a software developer? Okay. And of you, who enjoys working on a project that you inherited from someone else? Okay, this is more hands, like percentage-wise, than ever. So that's like I think it says something about this community. Usually I get between like 5 to 10% of respondents, but they're usually pretty enthusiastic. Like I got one very enthusiastic hand in the back. So that's what, yes? Am I too quiet? Yeah. Okay. Yeah, I'm kind of soft-spoken, so thanks. Awesome. So I absolutely love working on projects like that. They're my favorite. And it's something like I get giddy about. I love to dive into a code base that I have no experience with, figure out my way around, fix some bugs, make some improvements, do some refactoring, write some tests. Those are all things that I like those. That's the kind of work that I really enjoy doing. New feature work is awesome, but it's not what really gets me excited. Like figuring out how to add a new feature into an existing system, that does get me excited. So like building something brand new from scratch, like not that's not what gets me up in the morning. And I like doing that so much that I decided to co-found a company that focuses exclusively on that. We don't build new systems from scratch. Our philosophy about software development is that there are two kinds of software developers. There are makers and there are menders. And the makers love building new things from scratch. They love that creation. They get a lot of joy from that creation. They like getting something to about an 80% solution and then moving on to the next thing. Whereas a mender loves the art of refining. They like taking something and improving upon it, polishing it, finishing it, making it more stable. Those are all activities that a mender really enjoys. Yeah. So today what I'd like to tell you is a story about a time that my team had to build a bridge to an older application. And I'm going to talk about the challenges we encountered, the things we tried along the way, the things we learned. And about this particular story, I don't want to give away the industry that my client was working in, so I'm going to be like really, really vague about a lot of details, so please forgive me for that. So the story starts with an old colleague of mine who I'm going to call Jeff, not his real name. And Jeff and I had worked together on a lot of systems in the past, and he knew that I really loved a challenge and that the team that I had assembled, we also really loved a challenge. And he was working for a startup who was focused on building a web API, universal web API for a very fragmented industry, and an industry that hasn't really innovated much over its lifetime. And some of the constraints about this industry, the systems that they're working with are usually in physical locations, involves interacting with the general public, and it involves staff at that physical location, using these systems to provide value for the customers who come in off the street. And the vendors in this industry were not very well known for adding new features and kind of innovating on top of their platforms. But a lot of the organizations that were using them really, really wanted that. This was also a very sticky industry with a lot of very unsatisfied users of all the vendors in that industry. If you surveyed them, a very large number of respondents would say that they're extremely dissatisfied with their current vendor. Well, you would also ask them whether they're likely to change vendors in the next 5 years. They would say they're extremely unlikely. So even though most of the people who are using these vendors are extremely dissatisfied, they're also extremely unlikely to make a switch. So it's a very tough market to enter into in terms of like standing up a new vertical. So that's where my friend's company's idea was to come in and like build a layer across all of these vendors. That's one kind of consistent interface that people could then innovate on top of. The typical integration, the way these were built, is there would be some form of connector that that communicated in with the vendor system. And Jeff's company had built a lot of these. And the connector would usually be installed like directly on the system that the vendor system is installed on. And that connector had its own own contract, its own API between the public web API that Jeff's company sold. And he wanted to integrate in with a new client. A client approached him, but they were using a vendor that his company had not integrated in with before. And when he started digging and learning more about the system, he was told that this particular vendor has no SDK. They have no way to integrate in with their system. And this is going to be a really big client for Jeff's company. He's really hoping to find a way to land them. His team had tried some experiments. They weren't really getting anywhere. Everyone they tried calling at the vendor's company was, pretty silent on the fact of, whether or not there was an API that might have been hidden that maybe they need to pay somebody to get access to. There was a lot of, from the looks of it, there was no way for them to get at the information. So he wanted to see if my team would be interested in digging in and trying to figure out how to get the data that his system needed to put together a read-only prototype for this API, with the idea of one day building a read-write solution. So there were some details that we did know about the system. It ran on a Windows desktop class server in quotes. So it wasn't a server version of the OS. It was a desktop version of the OS, but it was serving a server function. It had some way of storing its data, some mechanism for data storage, but we didn't really know what that was. We did know it didn't require an extra box, so whatever was storing the data was getting stored directly on that desktop. There was an admin UI that could be accessed from either that same Windows desktop or a different Windows desktop on the network. And then lots of other Windows desktops and other devices would then communicate with that server. So we dug in and we took a look at what are some of our options for attacking the system. So we came up with several ideas. We could try to hunt for an undocumented SDK. So based on the assumption that the team that was working on it had some form of building abstractions, and that somewhere buried beneath the covers, if we go looking for it deeply enough, we'll find whatever that team is using to make their lives easier, and then we can use it, instead. We can try to find the libraries that communicate with its database and just communicate with its database directly. And so, that was another idea we had. Another idea that we thought of was actually screen scraping the UI. So, we could tell by interacting with the admin user interface and by running the client applications that all the pieces of data that we needed to expose to the web API were there. And we could mutate them, we could see them on the screen. So that was one of the ideas that we had, was maybe we could do that. And what we were really, really excited about, and what we really hoped we might get to do, was actually figure out where the data is actually stored in a very raw form, and reverse engineer its database file format. We did some quick experiments and discovered that screen scraping wasn't going to work, and there were a number of technical reasons for that. One was the way a lot of the text was being rendering wasn't making use of normal Windows controls. It was actually just generating the text inside of a bitmap and then rendering that bitmap on a screen. So, right. So we would have had to do some kind of OCR in order to then convert that back into the text we would need. We weren't really confident in our ability to find an OCR library that would do that for us with a high enough degree of fidelity. So we skipped that. We also noticed that the client UI, we would have needed to get some information out of that. We couldn't get everything we needed out of the admin UI. And one of the features of the admin UI was to change where user interface elements appeared inside the client UI. So that would have added an extra degree of complexity for us, in terms of our understanding of the system. We would have to then know how it's configured to display its information so that we could go grab it in the right places. So definitely a very complicated way of having to go about it. So we came up with this basic plan of attack of first we'll try to find an undocumented SDK. If that doesn't work, then we'll try to find the libraries that communicate directly with the database. And if that doesn't work, then we'll get to the fun part, hopefully, which will be us attempting to reverse engineer the file format. So first it was like, all right, maybe there's an SDK, let's go hunting for it. So how do you go hunting for an SDK? So we visually skimmed the installation directory, looking for anything obvious. One thing we did find was evidence of very, very old tooling. Does anybody in the audience recognize this icon? Yeah, okay, I see a couple, I've got some chuckles. So this was the default executable icon for very, very old versions of Visual C++ when you're working with MFC specifically. And many of the executables that were in this directory had that icon. So that gives us some kind of indication that a lot of the binaries that are in that directory were at least at one point in time built with incredibly old tools. The Windows SDK has a utility called dump bin, and you can use this to get lots of information out of DLLs and executables in terms of what functions are in there, things you might be able to call with or without a header file. So we ran dump bin on all the DLLs and executables that we could find, and we didn't find anything that looked like it had the kind of information we were looking for in terms of values that might indicate it would contain the data we're looking to get out of it. So there was nothing obvious, and that was took quite a long time. And so we're like, well, all right, so strike out there. Let's go see if they're using an off-the-shelf database. So we went looking for the database access DLL. To start, at first, we looked for evidence that they might be using like some kind of commercial off-the-shelf database storage solution. And if you can name a database, we weren't able to find evidence of it. We looked for DBase, we looked for access, we looked for just plain text flat files, we looked for XML, pretty much any in-memory database or embedded database that we might be able to find. We weren't able to find evidence that any of those were being used. We took a second pass through the dump bin output and looked for anything that looked like it might be taking like an SQL expression and getting like a chunk of data back, or just something that might be just giving raw chunks of data or just being used purely for raw data access. We didn't find any of that. We did find a few .NET DLLs that we missed the first time. We tried to decompile these. They were so obfuscated that it broke all the decompilers that we had access to. So that started to give us an indication that the team that we were kind of virtually fighting against didn't really want us to attempt what we were trying to do. But again, we were left with nothing obvious. So at this point, we kind of like threw a mental party, and got really excited because next is like, okay, let's attack where the data is actually stored on the disk. We know it's stored somewhere. Let's find that. And this is kind of where we had an internal fight on the team to figure out who's going to get to work on the project. So the first challenge we had was to like actually find the files that are getting changed. So the first strategy we tried for that is we copied off the installation directory. We opened up the admin UI. We made one change, and then we diffed before and after. And we got lucky. There was only one file that changed, and it had, I don't remember the exact extension, but it was something really generic like .bin or .dat, like very nondescript in terms of what might be contained in it. So we opened up our favorite hex editor. And for us, we were working on a Mac, and so we were using Synalyze It. Synalyze It is an amazing hex editor if you ever find yourself in need of tackling the kinds of problems it solves. It has the ability to kind of map out in a very color-coded, almost syntax highlighting structure, a binary data format, and you can specify your own data definitions inside of it. And there's some rudimentary support for generating parsing code from these definitions as well. There's definitions it ships with, so you can like open up a JPEG file and see what that looks like. You can go up a PNG and see what that looks like. This screenshot was one that I took for opening up a DBase file that was publicly available. Synalyze It is macOS only, so if you're not on macOS, the same company makes Hexinator. It's a much more intimidating logo, but it does look like it's the exact same functionality. So check that out if you're on that platform. And I have no affiliation with this company. I just think it's an amazing tool, and people should try it if they have similar problems. So the first thing we tried to do in the hex editor was just scan and search for strings, things that might look like they might be table names, things that might look like they might be column names. We did find a big chunk of what looked like table names, and the section where these table names appeared started to have a structure to them. And so we were able to like highlight the repeating structures and symbolize it, and see that like in addition to the table name, which appeared in like a fixed column width, that there looked like there was some other metadata about the tables as well. And then we did some experiments with, when maybe some of these values are offsets to other locations in the file, and so we went and looked at some of those locations, and we got lucky and found another set of similar definitions which looked like they were column names. So now we're starting to be able to drill down, like we found the tables, we found an offset in the file where the column names for that table are stored, and each of those column names has a little bit of metadata about like what looked like a data type and how many bytes that field might take. And so we were able to kind of keep churning along that way. So this is very much. So next thing we really had to do was kind of go through like what I thought of as a grind. Like now we have a pretty good idea of how to get at the data, but now we have to like find all the fields that we need to get out of the system and start to map their locations in the file so we can read them in a reliable way. And for this, our basic strategy was to make a change either in the admin UI or on the client. We would diff that binary file before and after. And Centralize has a really good mechanism for doing a binary diff. It'll highlight the exact bytes that changed before and after. We would mark that location as Centralize it. We would give it a name that we thought made sense in the grammar. And then we repeated. We did only focus on what we needed. We didn't try to like exhaustively map out the file format. That wasn't our goal. The data we were trying to get out of it probably comprised maybe 20% of the data that was stored in that file. So for us to do it exhaustively would have been a waste of time. And then we also had to validate some assumptions that we had about data file formats. We would write values in that would force us to test assumptions about byte order in terms of how the data wasn't stored, whether it's big endian or little endian. Also, like, is this a floating point? Is this a floating point value? Is it a decimal value? Is it a length prefix string? Is it a variable length string? We did a lot of tests to really kind of validate our understanding of the different data types that could be stored in the file and how they were being stored. So then we needed to build the actual connector to build out the API. And so we only implemented the read commands because that was our task, was to put together a read-only prototype. The goal was to delay a read-write experiment until after the demo, but we did come up with some ideas about how to experiment with that. One idea was to copy the file off. The thing we were concerned about was that we might be writing to it at the same time that the actual system is trying to write to it, and so we're nervous about corruption. So one way was to experiment with OS level locks to see if the OS would allow us to get a lock on the file and keep the other application from getting a lock on the file, and hopefully us having a lock and them not being able to get one wouldn't cause it to crash. So that was one idea we had floating around. Another was to just copy the file off, make our writes in the copy, and then compare to see if the original had changed, and then we can safely apply ours within some margin for race conditions, of course. So nothing we were too happy about. Definitely didn't feel like a foolproof solution, but we were excited to give it a try anyway. So what we ended up building out was, we had essentially built a custom SDK that we could then drop into the typical block diagram, and then we're able to build out the connector to communicate with the external API. We had everything working, and then we got time to actually demo this implementation to the end client who was using the vendor system at a physical location. Excuse me. So the details of the demo, come to me like second and third hand, so I don't know how accurate all of these are. The gist of what I was told is that there was some representative for the vendor, a very technical representative, maybe a CTO, who was on site at the demo, and that person was extremely alarmed that we were successful. And one of the reasons that they were extremely alarmed is because it turned out there was actually an SDK. So we had done all this work, and that there was an SDK, but it was like a separate installable, something that had to be installed in addition to what we had to work with. When they found out that we had plans for read-write, like their department just handed the SDK over, and so we were like able to cut through a lot of red tape, I guess, that may have existed. I can only speculate about why this was happening. My best guess is that the marketing department for the vendor was really excited about having a third-party company come and be able to add this capability onto their platform without them having to pay for it. And perhaps their engineers felt a little bristled by that someone from the outside is able to add capability, essentially add capabilities to their solution without them having any input on it. I don't know. Our general reaction was a big bummer. We were really excited about being able to push this idea forward, and thought at the very least our read-only solution would have gone into production and it would have been sold in a read-only way. And yeah, but instead all that work we did just essentially got thrown away. So I tried to slow things down and say, okay, not so fast. We did learn a lot. We had a ton of fun along the way. And our work did lead to the best possible solution being uncovered. Like the stability of the system is much, much better when there's an off-the-shelf SDK provided directly from the vendor. Us building an SDK on top of that, where there would have been issues with a new version coming out and then us lagging behind that, or there's likely an assumption we had made, even though we tried really hard to validate them. There's likely an assumption that we made that was wrong somewhere along the way in terms of like how the data is being stored, and and our ability to read it out. So that likely would have been, a little, some friction that was created along the way. And then the read-write solution would have been incredibly risky. We certainly would have tried. We would have worked really hard to make sure that we had all the problems we could think of solved, but there would have been problems that we hadn't thought of. And there likely would be race conditions that would happen in a production environment that would be very difficult for us to try to simulate. So I do think that the client ended up with the best possible solution. And so that's the end of my story. My favorite part of a talk is the Q&A, so I'd like to facilitate a Q&A session. Before I do that, this is my contact information. If like this story sounds fun and kind of working on these projects sounds fun, we have an online community that we call Legacy Code Rocks, and it's hosted at legacycode.rocks. We have a podcast by the same name. We have virtual weekly meetups, mastermind sessions that we encourage people to attend. So if hanging out on Slack and chatting with other people who enjoy banging their heads against legacy code sounds like fun, come check it out and say hi. So questions? Oh, sorry.
Why were you never able to, the SDK,
Mm-hmm.
I'll just say I have Windows reverse engineering assembly code background.
Right.
Why is the database driver only shipped separate in the SDK? Why couldn't you figure out where the DB driver was in the original app? And wasn't it probably JetDirect anyway?
I don't know. My best guess is that it was. Okay, so the question was like, why weren't we able to find if there was an SDK anyway?
You said you already used Dumpin, so you would have found
Right.
the entire SDK anyway in one of the DLLs that made up that app.
Right. So like, why weren't we able to find any kind of SDK if there was one, or database driver or anything like that? My best guess is that this was a pre-SQL database built entirely in house, and that.
It was MFC, so I assume it's JetDirect or Microsoft SQL.
Don't know.
They would throw
Right.
it off.
Yeah. So the off-the-shelf solutions, I don't know if they use them. I have no way of knowing. My best guess is that The SDK was, a duplicated chunk of code that installed separately. And it could be the way they were compiling, names were getting mangled, things were unobvious. Could have been compiled on the executable, yeah. So it was no external library.
Driver would have been static code length and invisible.
Right. That's, so that's my guess. And we didn't go digging, we didn't try to attach the assembly debugger to the running process and try to find where the data was flowing through. We could have done that once we knew some of the values we were looking for. We could have tried some of that, attach WinDBG, tackled some of those, gone through some of those investigations. But our ultimate goal was to, get at the data and put together a proof of concept to try to help the company complete a sale.
Did you ever try using FileMon or strace to see the server app writing to disk and reverse engineer from disk IO logging?
No, we didn't do that. No, we didn't try strace. We just, we just basically looked at the directory and got lucky that the file that was being edited was there. We're going to try going that route if it looked like its file was not in the directory that it was installed into. If maybe it was being installed in some other location, or if there's a Windows service that we didn't know about that was running. Then we would have explored other ways to do operating systems level tracing to see what kind of disk I/O was going on, to try to figure out where the file was at, especially if there might have been multiple files. I do think we got lucky in that it was only one binary that was being modified, and it was in the installation directory, so it was very easy to see by just doing a sort on date modified to find the file that changed.
You're really lucky that the entire SQL DB didn't have an absolute length or a corruption CRC that would make writing impossible.
Yeah, we never tried writing, so we only tried reading. But yeah, you're right. I mean, if they did have any kind of cryptographic check, or even just a simple CRC, us writing to it would have been impossible without their keys, or without knowing the exact algorithm they were using to encode that. So. Mm. Yeah. So the comment was that even if they were using encryption, some kind of encryption mechanism or some kind of cryptographic signature, that signature would have needed to exist in the file system for that executable to write to it. So we could have hunted for it. So. The question is whether we maintained a firewall between the people who were doing the reverse engineering and the people who were doing the implementing. No, it was the same. It was the same. Couple of individuals that was doing both work. So, any other questions? Okay. I wasn't at that meeting. I don't know. Maybe. So the question was, yeah, the question was, right. The question was, did was the company trying to get extra money for the SDK? I don't know. You also mentioned that wondering whether or not there's a communication breakdown. I think there had to be. So because the story, as I was told, because again I wasn't part of the communications with the vendor. I was, my client was in between us and them, and I got the impression from them that they had tried everything they could think of to try to get an SDK or some documentation for how to integrate in with the system, and they were just told that it's just not possible. There's no way, and so that was the reason that we got called. Was we liked hearing things that are impossible and then trying to tackle them anyway. So, yeah.
Curious if your access to the SDK helped you discern, hey, we did something right here, or we did something wrong here, or was there anything that you got out of the SDK that you were speculating on previously?
Yeah, so the question is whether or not, once we got access to the SDK, if that gave us any kind of insights and helped us validate some of the assumptions we made. What was kind of sad for my team is we didn't get to see that. So the SDK went to Jeff's company, and once Jeff's company had it, they were like, well, "We've got this." So they didn't really need our technical expertise anymore. So pretty much all the effort that we did was was tossed. They may have been able to preserve some of the logic we wrote in like that little connector app in the diagram. They could probably could have preserved that we wrote, but pretty much all they really needed to do at that point was to wire that up to the actual SDK, and then they were done. So they didn't really need us. So I never got that insight. I guess I could reach out and find out, but. All right. Well, if there's no other questions, thanks for being awesome hosts at YAPC. I've really enjoyed the conference so far, and I'm sure we'll continue over the next couple of days. Please reach out if you want to keep the conversation going, and hopefully, like just the pure joy that my team had working on this comes through. We just absolutely ate this up like candy. There is one of our podcast episodes is an interview with the other developer who worked on this project. And she did like almost all the grinding work that I described. I was more involved at like kind of a strategy level, like kind of helping like say like, okay, let's try this and then this and then this. She was the one who really did all the grinding work. So yeah.
I have one question. What's the most common thing that you, since your company was doing, integrating or what's the most common problem?
Okay, so the question is, since my company focuses on helping with legacy code, kind of what's the most common problem that we help with? It's mostly teams getting stuck and feeling like they have to bulldoze and start over, but not wanting to. So helping them get unstuck from that. There are a lot of factors that play into that, but that's really like the kind of the inflection point that a lot of teams get to, is they're so frustrated with the mess that they've got that they're not sure how to get out of it, and their intuition is that the only way to get out of it is to bulldoze and start over. So one of the things we advocate strongly for is to not bulldoze. Try to find ways to harvest what you've got and start making it better by improving it. And that's something that we find a lot of joy in, and we've noticed that a lot of developers who their preference would be to bulldoze and start over, they hate that work. So that ends up being a lot of what we see, is that kind of helping people who hate doing that cleanup work not have to stress about it anymore, and then we can focus on that stuff while they're focusing on continuing to make messes. Then we can help focus on keeping them clean. So, well, awesome. Thank you all very much.